One-time limits. Let's look at the functions we're provided, 1, 2, 3, and 4, and let's visually determine the limit as it approaches from the left and right the specific value. So as this function approaches 2 from the left-hand side, we would be approaching an output value of positive 1. And as this limit approaches 2 from the right-hand side, we would be approaching an output value of positive 3. Number 2, as we approach negative 1 from the left. So as we approach negative 1 from the left, it is approaching an output value of positive 4. And as we approach negative 1 from the right-hand side, so from the right-hand side, it's coming down here, and it's approaching, and again, it's converging on the point 4. Let's look at the graph of number 3. As we approach positive 3 from the left, it is headed to negative infinity. And as we approach 3 from the right, it's headed to positive infinity. Number 4, we can see a hole in the graph. As we approach negative 2 from the left, it is approaching an output value of negative 3. And as we also approach negative 2 from the right-hand side, it is converging on the same point of negative 3. Okay, let's take a look here and first try this algebra. When it asks me to approach 2 from the left, I am going to choose the first part of the piecewise function because these are values that are less than 2. So in this function, I'm going to substitute 2. Half of 2 is 1, and 1 plus 3 is 4. Now here it asks me to approach the limit of 2 from the right-hand side, and this is where x values are greater than 2. So I'm going to substitute 2. Negative 2 plus 4 is 2. Because these two are not converging on the same point, this limit does not exist. Let's look down below at number 6. So first I'm going to evaluate this function at negative 3. Negative 3 squared is 9 plus 4 times negative 3 minus 3. I'm simply substituting negative 3 where I see an x in the function. 2 times 9 is 18, minus 12, minus 3. 18 minus 12 is 6. 6 minus 3 is 3. All right, let's go ahead now. Let's move over to the right-hand side. In the right-hand side, I'm going to do the same thing, and I'm going to move this up to provide myself space. I'm going to come back here, and where I see an x, I'm not going to substitute an x plus 2. 2 times x plus 2 squared plus 4 times x plus 2 minus 3. Again, substituting x plus 2 into these places. So I'm going to start by foiling x plus 2 times x plus 2. That's often a common mistake I see students make. When I foil this, I'm going to do the fronts. Now when I do the outside and the inside and combine them, it's going to be 2x and 2x, which combines to 4x, and 2 times 2 is 4. The last part is very elementary. I can distribute the 2, distribute the 4, and combine like terms. 2x squared plus 8x plus 8 plus 4x plus 8 minus 6. When I combine this, I only have one group of 2x squared. 8x and 4x is 12x. 8 plus 8 is 16, and 16 minus 3 is 13. Let's move on. Same concept, but now I'm going to substitute an x plus h instead of an x plus 2 into this original function. So f of 8x plus h is equivalent to 2 times the quantity x plus h squared, which means I'm going to write that quantity twice, plus 4 times x plus h minus 3. When I go ahead and I distribute or FOIL, I multiply in the fronts. Now when I multiply the insides and the outsides, I'll have two groups of xh. Two groups of xh plus h squared. I'm going to distribute the 2. distribute the 4, and then combine like terms. 2x squared plus 4xh plus 2h squared plus 4x plus 4h minus 3. Let's combine like terms here. When I combine like terms, I'm going to start with the x. There's only one group that has an x squared, 2x squared. Now I'm going to combine the groups that have an xh. So I'm going to cross. There's 4, and there's only one group of xh. So plus 4xh, okay? Next, I'm going to combine the h squared. There's only one group of an h squared, plus 2h squared. And now these can't be combined. They're not like terms, so plus 4x plus 4h minus 3. Okay, so in part D, I'm going to take this quantity, which I already was able to come up with, and I'm going to subtract f of x. 2x squared plus 4xh plus 2h squared. This is f of h plus x, and now I want to subtract what f of x is, which is 2x squared plus 4x minus 3. Keep in mind I'm putting a parenthesis around that entire quantity because I do need to distribute the subtraction sign, and that's all going to be over h. Let's combine like terms up top. So when this is distributed, it becomes a negative, let me switch colors here, it becomes a negative 2x squared, and it becomes a negative 4x, and it becomes a positive 6. Combining like terms. The positive 2x squared and the negative 2x squared are going to be eliminated. The positive 4x and the negative 4x are going to be eliminated. And I'm left with 2h squared. Did I add something wrong here? I know what I did. I meant to put an xh. See how I had a 4xh? This would have been a 4xh. So this negative 4x should have been canceled with this. So here's the positive 4x, and here's a negative 4x. Those two are additive inverses. Exactly the same part of the expression, 4x and 4x, but one's positive, one's negative. They're going to cancel. This, I forgot to bring an h down, so I'm going to put that back up here, 4xh. So here is plus 4xh. So I have this remaining, and this remaining, and this remaining, and then negative 3 and positive 6 combined to give me a positive 3. Now that's all over. Okay, as I'm moving this up, I'm asking myself, why did I put a 6 here? I think by swapping a solid 2, a negative times a negative is a positive 3. So this should have been a positive 3. My apologies, I can't go back here and erase that part. The positive 3 and the negative 3 again are additive inverses. They are going to cancel themselves out. Okay, what else do we have? Alright, we're just about done here. Sorry about my multiple small mistakes here. This h needs to be shared with everything up top. Okay, it needs to be shared with everything up top when you divide. So I'm able to think of this as h times h. And so this h and this h, okay? Or if you like to write it like this, you can share it as so. It has to be equally shared with every single term up top. Now, one h on top and one h on the bottom are going to be simplified, and I'm left with, remember, this is the same as h times h. So 1 on the top and the 1 on the bottom are simplified or canceled. I'm left with 2h. Here the h's cancel, I'm left with 4x. Here the h's cancel, I'm left with 4. Now remember, this entire thing was going to be to evaluate the limit as h goes to 0. So what I do now is I substitute in 0 for h. Well, 2 times 0 is 0, and what am I left with is 4x plus 4.